Good morning, good evening, or good afternoon. I hope you guys are having a great day. This is Miss Abney. I am going to go over topic 1, lesson 1-6, example 1. I will make another video for the try it so that you guys have some more resources, some more examples. In this example, we're going to go over how to solve these things algebraically. In the model and reasoning, you saw me start the algebraic process to solve these type of equations. So this one says, what is the solution for the system of linear equations? So let me clear my board here. And I have it right here. So what is the solution of the system of linear equations? We're going to have to find both an x and a y here. So what they're asking for when they say solutions is an x value and a y value where these two lines intersect, or where these two lines are the same. So the first thing I'm going to do in this type of equation, and there's two ways to solve these. So this way, I'm going to show you this method called substitution here. And then the next method, I'm going to show you how to line these up and change the signs and things like that to just kind of solve for one of the variables. So that would probably be in the try it. All right, so the first one is solve both equations for a single variable. In this case, I'm going to pick the variable x. Typically, you would solve for y, but if I solve for y in this case, I'm just going to do it here in the corner, we would be left with fractions. I'm subtracting x from both sides. So we get 2y equals 3 minus x. Divide that by 2. And we get y equals, and remember when I divide by 2, this 3 and the 1 that's hidden there also get divided by 2 when we break it apart. So 3 halves minus 1 half x. And here we're dealing with fractions. And as much as I like dealing with fractions, they're a little bit more difficult to deal with in the long run, doing the fractions all the way through. So what we're going to do is we're just going to solve for x. So in equation 1, I have x. Let me erase all this here so it's not confused with some of the math that I'm going to do here. That was just my example on why I'm going to choose x. So x plus 2y, and this is the equation 1, and this is equation 2, equals 3. So here, all I have to do is just subtract 2y. And now I get an x equals. And now I've solved for a single variable. I'm going to do the same on the second equation. Add 2y in this case. And then I get x equals 4 plus 2y. All right, so now what I'm going to do is I'm going to, the step 2, substitute the variable. Equation Q-A-T-I-O-N. So I'm going to take, so I know that x equals this value, and since x equals this value, I'm going to substitute this value in for that x. So now I get 3 minus 2y equals 4 plus 2y. Next step, solve for the variable. All right, so now we are looking at 3 minus 2y plus 4, not plus, equals 4 minus 2 or plus 2y. There we go, this plus. I'm going to add 2y to each side, get my variables onto a single side of the equation, get my constants onto the other side of the equation. So we get 3 equals 4 plus 4y. Subtract 4. I get negative 1 equals 4y. Divide by 4, because again, I want to get this y by itself. I am solving for that y, and I get negative 1/4 equals y. I'm going to keep it as a fraction. Fractions are seen as more precise, while decimals are approximate. So I'm going to keep it as a fraction. Okay, the next step. 4. Substitute the value into the two equations. And we're going to make sure both of them equal each other. All right, so the first one is 3 minus 2y, so x equals 3 minus 2. And I'm going to substitute y, so y now is 1/4. So I'm going to substitute that into this equation. So negative 1/4. And then the other equation is x equals 4 plus 2y. Yeah, 4 plus 2y. And again, this is negative 1/4. So x is going to equal 3 minus, or plus, because the negative times a negative is a positive. 2 divided by 4 is 1/2. This is going to be x, so I'll continue on this one. X is equal to 6/2 plus 1/2. So what I did there is so that I could add across, I got the same denominator. So x equals 7/2. Let's see if we get the same here. 4 plus, or no, not plus, because a negative times a positive. So there's a negative times a positive will give me that negative. So minus 1/2. See, 4 would be 8 divided by 2. So 8 divided by 2 gives me that 4. So I'm again getting the common denominator. And x equals 7/2. So my point, these two are exactly the same. So this is my point. My solution is 7/2, negative 1/4. And this is the solution. So if I were to graph these two, they would intersect as 7/2. And this shows us in here, they show us. So we're doing a system of linear equations. As a set are two or more equations using the same variables. The solution of a system of linear equations is that the set of all ordered coordinates that simultaneously make the equations in the system true. So I would take a moment, pause the video, and I would write this down. All right, so when we look at the graph, and like I said, we're looking at the graph. We're looking at this graph, and it does not intersect at a nice grid point. So we did the algebraic method for it. And this one just goes through how they did it. This is how I did it. And they found that y equals 1/4. They used substitution. And they got the solution as 7/2 and negative 1/4. And you could confirm this by, if you want to put this equations in Desmos, you could confirm this by seeing where they actually intersect. Desmos is really great at letting you know the decimal points. You might have to convert these into decimals. So it's 7 divided by 2 and negative 1 divided by 4 in a calculator. Hi, so the next video I will be doing example 2. I will also produce a video for the try-its if you need some extra resources. So I hope you guys have a great afternoon.